I think that's the first for me. I mean, to be introduced to my lecture with a bagpipe, a set of bagpipes. That's marvellous. I thought really, really interesting. Well done. I'm not sure how to follow that actually. I'm afraid. Anyway, yes, the first Super HiVision Olympic Games. An interesting event last year. Lots of things happened. It arose out of obviously NHK have been working on Super HiVision for a while, and we in BBC Research and Development started collaborating with them in about 2007, and we did some experimenting for 2008, transmitting live signals to the International Broadcasting Convention in Amsterdam, and then things grew from there. And last year the event that we did with NHK was the biggest event that had ever been done with Super HiVision. Well, just for those of you who are not familiar with Super HiVision, it is a class of ultra high definition television, and it was NHK designed it with this sort of idea in mind. What they wanted was, in your living room, they wanted you to have a totally immersive high definition experience. So what they wanted was a picture on your living room wall that would actually fill your field of view. They ended up after doing some tests to make it 100 degrees as your field of view. And so when you do that, you do the calculations of a typical living room, even quite a small one in Tokyo, it actually comes up that you end up with a screen that actually has to have somewhere around 8,000 pixels across and 4,000 lines. And that means if you've got those dimensions and the screen's big enough to fill your field of view, you can see the smallest details. You won't, the pixels will just not quite be visible. So, given that as a design criterion, they also thought, well, actually, immersion is not just video, it's the audio. As I almost forgot this morning, I'd only just plugged in the audio to my laptop. They thought, well, how do we get an immersive audio experience? And they came up with the 22.2 channel multi-channel audio idea. And where it came from originally was actually it came from three 7.1 systems set at three different levels. One at ground level, one at mid-level, one at top level, and then the 22nd speaker was a speaker directly above. That was a practical thing that NHK did when they first started to research. They've adapted it now and evolved it now, and the speaker positions have changed, and there's a lot of research into how to make that really good now. Okay, so technical parameters for it. As I say, it's 4,360 lines with 7,680 pixels per line, which equates to 33 megapixels. That's 33 true megapixels, unlike the Bayer pattern. That's an RGB site at every pixel. 60 frames progressive. That's how they started off. Obviously, Japan is about a 60 hertz TV company, and the aspect ratio is 16 by 9. Now, when they started to work 16 years ago, they really had to work with what they had, and of course then it would be ITU Rec 6, so 709 colorimetry, the 22 channel sound that I mentioned. And that's why there's a couple of reasons for the 16 by 9 aspect ratio. The other, it works out easy when you're doing the conversion between HDTV and Super HiVision. But also they decided that they thought the 16 by 9 was a good aspect ratio to have. Something for discussion, obviously. Now, since NHK set those parameters, there has been an ITU recommendation, BT 2020, interesting number to get for perfect vision, I think. And now that defines the current situation with Super HiVision. Now, some of those parameters have changed. For example, the colorimetry now has moved on to wide gamut colorimetry, and the number of frame rates has changed. They've introduced a higher frame rate, as well as cinema frame rates as well, and European frame rates. But I'll return to discussing that later. Now, the Super HiVision showcase itself, that was put together between NHK and the BBC and the Olympic broadcasting services, and it came out of discussions between BBC R&D and BBC Sport. BBC Sport have traditionally put large screens around the UK to gather people together in cities. Some of you may have seen them in various parts of the UK for big events, big sporting events, and they wanted to make that experience more immersive. It turns out that, of course, with Super HiVision you can't have large outdoor screens. The technology is not there yet, so we then decided to do viewing theatres. And so we found 3 sites in the UK. Japan had 3 sites for their public, and then there was a private site in the USA, and we put a small private site in the Olympic International Broadcasting Centre for the broadcasting VIPs to see. And I should also say, of course, to actually bring this about, we had associates. Quite a few organisations helped us out, mainly network people such as NTT, BT, our joint academic network in the UK, Giant, Internet2 and Cynet academic networks. Here's a video of what's of what happened. I hope there's some sound on this, or we can make the sound go up. Honestly.
Super HiVision is a format developed by HK. It's ultra high definition images, about 16 times the quality of high definition as we know it, and 22.2 surround sound. Most people who see it describe it as like looking through a glass window. NHK approached the BBC a couple of years ago and said, look, we've got this technology, would you like to film the games in partnership with OBS? Would you like to film the games for the first time in ultra high definition? It's exactly like the internet. What we're hoping to do in London 2012 is to be able to give people the experience of being at a venue. There's 3 cameras, and we're going to be in 4 venues, 1 venue at a time. We're going to be in the Olympic Stadium, and the Velodrome in the Aquatic Centre, and the basketball arena. Those images then go uncompressed to television centre, where we have essentially our edit production base. This is TC0. What we've done is strip it out and then put in enormous amounts of Super HiVision equipment. Most of it's first generation, bespoke and made. So over here, for example, you've got the racks. That's essentially where we're storing all of the content. This is where we'll then start to do some of the actual Super HiVision editing, and we'll start to put graphics. So some of these new machines are the first generation of Super HiVision graphics machines. Here we're going to create a small viewing theatre for the Super HiVision content.
History is being made.
So this is an 85-inch 8K plasma, and that will allow the crew here to essentially see what is going out to our viewing theatres in the UK, Japan and Washington. This is where the audio, the 22.2's processing will be done. So here we've actually created a replica really of what you'll have at the public viewing venues with the 22.2 speaker rig around as well. Here is where some of the network activity is going to happen that gets the signal compressed and sent over to the viewing venues in Tokyo and Fukushima and Washington and the 3 venues in the UK. We're working with colleagues NTT to be able to do some of this work. The BBC, right from the beginning of this project, really wanted to give an opportunity for audiences to also see this glimpse of the future. This is the Radio Theatre in Broadcasting House. It's one of our 3 public viewing venues for Super HiVision. This is where members of the public and some VIPs will come over the 3-week screening period to see Super HiVision for the first time. Essentially, it's this technical thing that we're mirroring in Glasgow specifically at the National Media Museum in Bradford. So this operation is being run live as we speak here in Bradford and Glasgow as well.
We began research in Super HiVision at NHK Science and Technology Research Labs in 1995.
This morning, actually, we've got the chairman of the Trust or Pattern and some of the trustees to come and see Super HiVision for the first time.
This technological development is going to further enhance people's enjoyment of the greatest show.
I'm delighted the BBC are involved in this project with NHK and the Olympic Broadcasting Services. I think our research departments have worked extremely well together.
Well, we've done it.
It's a great thing about working on the Olympics, I guess, that you get the chance to work internationally.
That was Tim Plimming. He led the project for BBC Sport because it's always seen that this was, it's not supposed to be a technology project, it's supposed to be an application. Let's get this technology used for a real purpose. And I led the project for the technical side of things. Okay, let's just run through a little bit more detail that you might have missed in the film. The capture was done with a super high vision camera. There were 3 super high vision cameras available, the 3rd generation versions with 1.25 inch sensors. They were 4K sensors, but there were 4 of them, and there were 2 green sensors and to get the 8K resolution, 1 green sensor was offset half a pixel horizontally and vertically with respect to the other, and that helped generate the 8K signal. 20 kilograms, they're fairly prototype ones. As you can see, the lens is quite beefy, but it's only 5 or 10 times zoom. But of course, the way you would use super high vision with the incredible details, you don't go for those big close-ups. You have to picture back and get a vista, and you look at the detail of the picture with you look around the picture with your eyes. The outside broadcast truck that you were seeing briefly. Not a lot of room in there, but it's mainly full of disc-based recording for uncompressed recording. That's why the poor guy in there is crammed into a small seat. He has to sit that close to the monitor. He's got a 4K monitor there, and he's helping the cameraman focus. He's got a remote focus control. The cameraman can't do the fine focus in his viewfinder for 8K. It's just too difficult. The audio capture was done with this single-point audio microphone array to gather the sound field for the 22.2 channel sound, and it was mixed locally at the Olympic Park in a truck that was kitted out with some equipment. And it may be difficult to see, but there are miniature and computer-style speakers in a 22.2 channel arrangement in that truck to give a pre-mix before it was sent back for further processing. And production and playout was done in a small studio television centre in London, our Research and Development Department's experimental studio, now closed, I'm afraid, and you would have seen that on the film. We got the signals back from the video and audio truck using uncompressed optical transmission, and we used, or NHK used, a system of 8 wavelengths, each carrying a 3 gigabit HD SDI signal. You can either think of super high vision as being handled as 3 gigabit HD SDI, 8 of them together, or 16 1080i style signals all in parallel. And as you can see, there were dual paths for diversity. We didn't want the risk of the fibre breaking for some reason, and we actually returned back an uncompressed signal back into the Olympic IBC for the VIPs, the broadcasting VIPs, to see an uncompressed signal. And there's the operation centre there again, absolutely full. Took about 3 or 4 trucks worth of equipment to get it here. Took several days to set it up and to take it apart again. The transmission parameters for transmitting to the UK and Japanese and indeed the American public viewing sites, we had to compress the signal to go over the networks, and the system is based on 8 1080p 60 video HDTV video encoders working in parallel, and the aggregate video bit rate from that was 280 megabits per second. Once packed, and then there was 384 kilobit per second audio, AAC coded audio, remember 22.2 versions of that, which was all packed into a 350 megabit per second IP packet stream to be sent out to the venues. And it's including an FEC of 20% FEC overhead, because this is UDP, it's real time, you can't afford retransmission, so no IP network that I know of, it's perfect, they all drop packets, so you have to do something to prevent that happening. And for practical reasons, it was actually 2 streams. The top half of the picture was sent on one stream, the bottom half on another stream. It was slightly more difficult to handle, actually. We had to keep those 2 streams in synchronization. Here is the sort of a cloud diagram of the network, distribution network. From Television Centre, it went out over the BBC network initially. Then it connected through to Janet to get to Glasgow and Bradford. But it went to London over an R&D network. Now, to go internationally, this was the one where we needed to get the all the research networks, several research networks from around the world to connect together. And here's a diagram showing how it went from Janet to Giant, and then across the USA to Japan. It went by two diverse routes, one via Internet 2 and GemNet, and the other one via SciNet. The performance of networks is interesting. I mean, a big discussion must be in this conference about the broadcasting going to IP production, IP distribution. And this really was interesting because 350 megabits per second is would be typical of not a distribution HDTV link, but maybe a contribution HDTV link. Would want to work at maybe not as high as 350, maybe even 200 megabits per second, but still with that ballpark. We found that none of those links were error-free initially. We found that errors came in bursts at various times of day and night. And to fix it, we had to collaborate with the network, so we weren't really sure where the actual errors were occurring. It's not immediately obvious in an IP network where errors are occurring. And of course, you had to change one thing at a time, classic fault finding, change one thing at a time, but then you had to wait several days to really make sure those networks were error-free. It did make it slow. It took several months to actually get those networks to work properly. But eventually we got all the public viewing sites to get perfect transmission. They worked very well. The international links needed a little bit of error protection. NTT added a second's worth of time interleaving to the international links, which gave them a 16,000 packet burst loss capability. The viewing theatres, thinking about the UK ones, Broadcasting House in London, the new Broadcasting House, worth a visit if you can get there. The National Media Museum in Bradford, another interesting place to see, particularly with your interests here. Lots of broadcasting history there. And the Glasgow Pacific Key Studios. They're a new studio complex as well. The projector was a JVC projector, liquid crystalline silicon. Again, that only had 4K transducers, but it had two green ones. Well, actually it didn't. It had only one green one, but that was on a piezoelectric transducer, and that was moved for each frame. For half a frame, it was moved. The pixels, the whole sensor was moved half a pixel horizontally and vertically. So it would actually be shuttered and show the two green elements in a frame and in sequence like that to get the 8K pixels. If you've not seen it before, that's 148-inch plasma, direct view plasma. Huge display. If it wasn't for people standing by, it wouldn't be so easy to see. That was used in the Olympic IBC and needs cranes to move it around. But fantastic picture you get from one of those. Multi-channel sound. For the sound, even in our small listening room, we actually had to put in a 100 amp supply to power the power amplifiers. So I hope you're going to have enough power at home for your 22.2 channel audio. Viewing figures. In London, in the UK, we had about between 3,000 and 5,000 people visit the various viewing sites. We could have had more. It was a case of audience management, but we had many positive comments from viewers. Just let a few of them run in there. One there, I'll need to get a bigger house, obviously, to get the screen in. Totally immersive. I look forward to seeing the show again tomorrow. Someone wants to come back. Better than 3D, interestingly. People found it more absorbing. Cheaper than buying a ticket. Not quite sure about that. And he says, I hope my neighbour doesn't get one. Maybe they're just thinking about the sound leading through to his house. Of course, in Japan, they had their public viewing theatres. They had the luxury of 600-inch screens, huge screens. I think you can get an impression of the screen from the Furai Hall Theatre there. And they had many more people coming. They because of the bigger screens, the bigger theatres, they could have several tens of thousands of people pushed through. So that was the Olympics. Really successful. Everyone enjoyed doing it. But we're actually now talking about Ultra HD TV now, and I think we're mainly talking about 4K at the moment. So, what are the lessons that we've got? The large screen telepresence experience really successful. People really enjoyed it. At the opening ceremony, people cheered and jumped up and down as if they were in the stadium. It was just absolutely fantastic. The public do appreciate the extra resolution. They love the detail that they can see with this system. We did also have these direct view LCD displays, 84-inch LCD displays, available for people to view, and they do look like a viable domestic proposition. And people would actually, yes, they said they would have those in their homes. But technically, 50 or 60 frames per second is not enough for trackable motion. On a big screen, when an athlete goes across the screen, they go blurred. You can't read the writing on their, their name on the back of their tops or anything, or it makes it difficult. Because of course, with Super HiVision, you hold the camera steady and you actually go across the screen. Whereas with HDTV or standard definition, you zoom in and you freeze the moving action because you track the camera tracks the athlete, and so you don't get that problem. Now, the new recommendation, BT 2020, has 120 frames per second in there. Interestingly enough, doesn't have 100 frames per second, which is the number that people think is needed in 50 Hz countries, such as the UK and Europe. That is being discussed at the moment about introducing 100 frames per second there. The problem actually is lighting. You may discuss this in some discussions here. If you have a frame rate that's not connected to the lighting, you can get lighting flicker. And of course, we do need a new production interface standard. We can't work with 8 or 16 times HDTV all the time. We do actually need a whole production standard to go with it. And the big question is, should it be a synchronous standard as we're used to with HDSDI, for example, or should we go for an all IP standard? Well, I have a few people to thank. I won't read out everyone's names. NHK, of course, put an awful lot of effort into this. NTT, BT and Janet all helped out, and the other research networks. Of course, Tim Pluming for leading the whole project. I thank them and many, many more people. Thank you very much for listening to me.
I'm sure there'll be questions, John.
If you'd like, I won't sure there'll be time, but certainly.
Are there any broadcasters in the audience who perhaps would venture a question? If not, I'd like to say that it's very interesting to see that to be a broadcast engineer, you have to be multi-skilled. You have to know how to handle and edit media. You have to know how to deal with electronic systems. You have to be a communications engineer. You have to be also a network engineer. You have to also be a power engineer as well. You have to understand the requirements for power, and so it's a multidisciplinary skills that's required from all broadcast engineers.
It is. I mean, broadcast. This isn't really unusual. I mean, it's slightly unusual because, of course, we are putting completely new equipment in, so you couldn't really rely on anything that was in the television centre studios. Even the power. We actually we had a studio which you'd think should have enough power because it runs studio lights, etc. We still had to get an extra 100 amp supply in for that audio to make sure that we weren't going to overcook the power supplies that were there. But certainly we are used to this and doing it as making outside broadcasts, etc. We have an ability to turn up at a greenfield site and get it all organised. And it's, everyone who was involved in it, there's a lot of help from people in the BBC, other bits of the BBC, NHK themselves. We all worked together and actually just turned everything was bare at the start, and a week later it was all up and running as an operational Super HiVision system. Yeah.
Okay, so thank you very much. Join me in showing our appreciation, John. Small token of our appreciation, I'd like you to give you a small certificate as a gift for that very much.
Thank you very much.